Today we're looking at still surds but expanding brackets. Now if you're capable at expanding brackets with algebra, then this actually shouldn't be too difficult. So we're just going to go through 3 or 4 examples. The process is one that you should know well. If we've got root 3 and then multiplied by a bracket containing 7 minus root 3, this root 3 outside the bracket must multiply everything inside the bracket. And so we have root 3 times 7, better written as 7 root 3. We also have root 3 times root 3, or more precisely, positive root 3 multiplied by negative root 3. Positive times negative makes a negative. Root 3 times root 3, for the moment, I will just write like that. So we've expanded the bracket. Now we need to tidy it up a little. 7 root 3 minus, we've seen before, root 3 times root 3 is just 3. We can't do anything with this. If this had said 7 root 3 minus 3 root 3, then perhaps we could say 4 root 3. But as it is, that's as far as we go. This example is very similar to the first one, except that the quantity outside the bracket looks a bit more complicated. Might have to be a little bit more careful. 4 root 5 multiplies the root 5. 4 root 5 multiplies the root 5. And now it also multiplies this 2, or more precisely, a positive multiplies a negative makes a negative. 4 root 5 times 2 is 8 root 5. 4 times 5 minus 8 root 5 gives me a final answer of 20 minus 8 root 5. Which leads us on to double brackets. Now different people do these in different ways, but however you approach it, you must multiply everything inside this bracket by everything inside that bracket. If your teacher would normally get you to draw out a grid for multiplying double brackets with algebra in, you can draw that grid out for this as well. It'll work just as well. The 2 multiplies the 4. The 2 multiplies the negative root 2. The root 3 multiplies the 4. And the positive root 3 multiplies the negative root 2 to make a negative root 3 root 2. And it just remains a question of whether or not we can tidy any of this up. Well, the whole number will not combine with either of these. The root 2 and the root 3, they are basically not like terms if we talk using algebraic language, so they won't combine. This negative root 3 root 2, I could write it as negative root 6, that would be acceptable. Nothing simplifies here, nothing at all. So whereas when you normally multiply out double brackets in algebra, normally there are a couple of terms which will join together, it doesn't seem to happen here. And we're just left with the 4 terms. I think I will write that as negative root 6. I could equally have left it as negative 3 root 2. That would have been fine as well. One last example, just to be careful of. Suppose you're faced with 5 minus root 3 all squared. Too many people skip the next line and then make a stupid mistake. You really must put in the double bracket, which the square tells you about. If you don't put this in, you're likely to miss out the two middle terms. Two middle terms that we got up here. So 5 fives are 25. 5 times negative root 3. 5 times negative root 3. And be very careful, negative root 3 times negative root 3. A negative times a negative makes a positive, and we've got root 3, root 3. Now, 25, now let's think, negative 5 somethings, take away 5 somethings makes negative 10 somethings. This is negative 10 root 3 plus 3. So this double bracket actually cancels, or not cancels, simplifies a lot. 25 plus 3 is 28, so we get 28 minus 10 root 3. There you go.